Hello everyone and welcome to the next episode in our game development series. So today is going to be a very special episode because today we are actually going to get something on screen. Hell yes. So last episode we created this spaceship object and our spaceship object had a couple of variables like a position and a velocity. Now this episode, what I would like to do is, hurry up, to actually get something on screen. So it's all black now, but that will change. So how are we going to do that? Well, we are going to use what's called immediate mode rendering. This pretty much means that you send instruction per instruction to the graphics card. So instead of sending one big list of instructions to the graphics card, you send one after the other. It is extremely inefficient and you shouldn't use it for anything that is remotely serious. But since we don't have the infrastructure set up yet that will allow us to send bulk data to the graphics card, we are just going to use this. And it will be fine, and it will be very nice in visualizing what we have done, and it will help us in the future as we are working on that more robust rendering system. So let me quickly, I just grabbed the wrong window there. Let me quickly get some paint over here. I actually prepared this. So what we want to do is we want to draw a spaceship, let's say. Now our spaceship is going to look somewhat like a triangle, since that just happens to be pretty much the easiest object to draw in OpenGL. So let's just make a little triangle here. There we go. And this is going to be about what our spaceship will look like. So the shape of our spaceship will be about this. So it's a triangle, right? So that's pretty much the easiest shape you can make in OpenGL. So let's just do that, and we will make a more symmetrical version of this, of course. So what we will have to do is we will have to send some instructions to the graphics card. And those instructions will pretty much say, all right, like start receiving data, then we actually need to send data, and then end receiving data. Then we need to actually show what we have drawn. And actually, before we do all this, we will need to clear the screen. Right, so clear the screen, then start drawing, and actually send some data, stop drawing or end drawing, and then we will show what we have drawn. We will discuss this, that, and that all when we are actually in our code. But the data itself is somewhat interesting, and I want to discuss it for a little bit. So pretty much what the data will entail are just these three vertices of our triangle. That's really all that our graphics card needs to know. It will do everything else by itself. In the next episode, I believe, we will be looking at something called shaders. And with shaders, you can pretty much make the graphics card do what you want, and then we will discuss in more detail what the graphics card is actually doing there. Because now we will be using default shaders, and those default shaders will be interpreting these vertices and drawing them. What they will do is they will receive a vertex point of our triangle. So let's say this one is minus 0.5, right? We have like the origin about here, and the Y position will also be minus 0.5. Okay, so we send that to the graphics card. Then the next one is going to be positive 0.5 on the X and minus 0.5 on the Y too, right? On the same Y level. And then the next one is going to be probably 0 on the X, and it's going to be about, let's say, 0.8 on the Y. So it's a little bit taller, right? I think that's about it though. So we just send that to the graphics card and everything should work. After we also do these other instructions, of course. So let's kind of put that. Let's see if I can get that over here. There we go. So we have like a little reminder of what we have to do. Oh, well, it's gone. All right. You know what? Never mind. We know what we have to do. So first we need to clear the screen. OpenGL just has a nice function for that. We can just call GL clear. And all that we have to clear for right now is the colors on the screen, right? So we will just call, let's say, what does it want? A clear buffer mask. And we would like to get a color buffer bit. There are some other things that you can clear, and we will talk about that later. It's not important for now. So once it comes up, we will talk about it. And all right, so now we need to begin drawing. All right, so let's actually call then GL begin. That is, I think I called it start on my paint program, right? Here we go. I call it start. However, OpenGL calls it begin. It doesn't really matter, of course. It's the same thing. So we are telling the graphics card that we will be sending, or we're telling OpenGL that we are sending data to the graphics card now. And we have two options. We can either give it a begin mode and say, let's say quads. And then OpenGL will complain because begin mode is old and it doesn't want to use begin mode. Instead, you should use primitive type. So let's just do that. Let's use this overload here, primitive type, and we will actually not be drawing quads. We'll be drawing triangles, obviously. We want to draw a triangle. With triangles, you can make pretty much everything that you want, except for points. Right, so 2 triangles, you can make a square. With more triangles, you can make any kind of 2-dimensional shape. So you usually want to draw triangles. In some exceptions, you might choose to draw quads or, well, points, since you can draw points with triangles. But you don't do that very often, I find. So we'll stick with triangles. And then GL end to stop sending data. And of course, here we will send the data. And then in the end, we probably want to swap the buffers. That's what it's called, to actually show what you have done. So I want to swap buffers. And you have to just imagine that there are 2 kind of screens, right? One that you're actually seeing and one that we are working on. And once you call swap buffers, you swap those 2 screens. So the one that you are seeing right now goes to the back, so to speak, and you can start manipulating that screen. And the screen that you've just worked on, you will show. Right? And then you go back and forth, and then you can just draw on a screen without manipulating it at the same time as you're actually showing it. It's quite useful. Okay. Let's just let's send some data over there. So how we do this is, well, quite simple. We use vertex 2. You could use vertex 3 too, but vertex 3 just sends 3 coordinates, so x, y, and z. We don't really need a depth, we don't need z for now, so we'll just use vertex 2, if that makes sense. Yeah, let's see. So what did we say? We said that the first one was minus 0.5 and the y was minus 0.5. Right, and we said that the next one was plus 0.5 minus 0.5, and then the top one would be 0, and then plus 0.8. I think we said something like that. Well, that's really about it. So if we start the program now, it should work. Let's see. Moment of truth. Oh yeah, I can see something, all right. There we go. It's a triangle, a white triangle. It's perfect. I love it. So one thing that I haven't mentioned yet, and maybe I should, so let's stop for right now. I did mention something about default shaders a little bit ago. Well, maybe it's a good thing that I explain something about shaders. So a shader pretty much takes in data that is sent, like all this data, right? All these vertices that is sent to the graphics card, and it kind of manipulates them to show them. So let's say we are taking in this point, then a shader might say, well, let's take that minus 0.5 minus 0.5 and let's just divide those numbers by 2. And then actually show minus 0.25 minus 0.25 on the screen. It could do that. Now, the default shader doesn't do that actually, and it keeps everything as is. And that has some consequences because OpenGL, this is a really inefficient way of wiping this out, by the way. OpenGL draws everything in a little rectangle of size 2 by 2, where this coordinate is, I believe, -1, -1, and this coordinate is 1, 1, and of course this is the middle then. And everything is drawn within here, so that is why we actually get a triangle kind of like this. However, later when we are making a shader, we probably don't want to take in points that are from -0.5, -0.5, but we really want to work with a real screen resolution. So let's say, I think our screen resolution was 1280 by 720. So we want to take in more something like 640 by 360, right? Coordinates like this. And then we need to transform them to map them to coordinates like, well, in this case, that would be 0, 0. And that we would do in a shader. But that is some, I think, some pretty useful background on shaders for right now before we will actually start working on it next episode. For now, we might actually want to ditch these and start working with our spaceship instead. So let's just say we want our first coordinate to be, you know what? We will make some values right here. I want to make like a middle X position, and that is really just the X position of our spaceship. And I want to make like a middle Y position, and that is just the Y position of our spaceship. And those are not public, and I will make them public because I need them to be public. All right. Do you work? Yes, there we go. Right, and then I can just use my middle X position and just subtract some amount from that. And middle X position and subtract some amount in the Y. Oh, middle Y, of course. Subtract some amount for that. And we can do that for everything in here. Right, so what I'm doing now, just to clarify, is I'm taking this middle position and I'm just saying, well, this point, this vertex here, is really -0.2 in the Y and -0.2 in the X. And this position, it's really just the middle, but then -0.2 in the Y and +0.2 in the X. Right, and the same for this position. So that's what I'm doing right now. So let's get rid of this. Then let's say, so the X -0.2, Y -0.2. Then the other one is X +0.2. Y -0.2, and then the next one is just the X plus nothing, and then it's the Y plus like 0.3 or 0.4. Let's just say 0.4. There we go. Keep putting spaces everywhere. All right. No, of course. I was like, why is that not working? But I'm missing a semicolon here. You may notice that this is really kind of useless. I can just use ss.x, but we might want to manipulate this later, so I'll just put that right there. And now, here we go, it's in the middle. But also, let's say, Well, that went really quickly. So I wanted to say, let's say I press my W key, so my X will start moving upwards. There you go. There it goes. So kind of a problem is that once I stop pressing the W button, it keeps on moving upwards. It takes it a really long time to go back. Oh, and there it whizzed past us for a second. Ooh, this is not ideal. So instead of a more quote-unquote physical approach, I would just like to get rid of the velocity stuff. It's not really useful for right now, so I will not be doing this. Instead, what I will be doing is, let's say accelerate. I want to change accelerate to move. And let's say just a change in X and change in Y. And then I just want to say, well, X plus equals its change in X and Y plus equals its change in Y. And that is much more useful because now if we don't call accelerate but move, we will stop moving the second we stop pressing our forwards and backwards buttons. Also, this is rather fast, so let's slow that down a little bit. Let's replace that by 0.5, so then everything will be cut in half. Let's go now. There we go. And now I can just move the thing around and it will work pretty much perfectly. Look at that. So now once I stop pressing the button, it will actually stop moving. That's quite useful. And again, you can see that after I press like W, it takes a second to actually start moving. So it moves forward a little bit and then it stops and stops. And after that, it really starts going. So we should solve that. And we will do that at some point, of course. And with that, I think we have come to an end. So this was kind of a short episode. It's kind of basic, but quite important. We can actually see our little rocket moving around. Oh, it's just a triangle, but you know what I mean. And we have kind of discussed the basics of what a shader is and what we will then be working on the next episode, making our own shader. And that will help us actually use our screen coordinates. So actually the pixels on screen is usually quite useful because now you can kind of see that our triangle looks equilateral. Like it's kind of square, to be honest. And we have made it a lot taller than it is wide. But you can see that it's actually on screen, it's kind of just as tall as it is wide, and that is because our aspect ratio, according to OpenGL right now, is 1:1, even though our real aspect ratio is 16:9. So that makes this triangle appear kind of thick, so to speak. All right, for now, I want to thank you for watching, and if you liked it, leave a like and subscribe to watch the next episode as soon as it comes out. And then I would like to wish you a very great day. Bye.